So this is a lesson on ionic bonding, and for ionic bonding you need to start with the periodic table. Hopefully you already know that the periodic table can be separated into metals and non-metals by this staircase, and that when you are looking at the periodic table you can find out an awful lot of information about each atom on the periodic table. So we've got our groups for the periodic table. So we've got group 1 through to 8. You might know group 8 as 0, and that's okay as well. Doesn't matter, it just depends what you've been taught. So each atom on the periodic table is found in a specific group. Now when we are talking about ionic bonding, we are talking about forming ions. So ions are atoms with a charge. So our metals are on the left hand side and they form positive charges. Okay, so all metals form a positive charge, and strangely hydrogen's in there as well, and hydrogen forms a positive as well, whereas non-metals form a negative charge. And then we just need to think about by how many. Okay, so we should know that each electron has a charge of -1. Bonding happens, particularly ionic bonding, by an exchange of electrons. So you're either going to give an electron away or you're going to take an electron in. So metals give away or transfer their electrons, whereas non-metals accept or take electrons from other atoms. So it's that transfer of electrons. If I give away something negative, I become positive. Now how many do I become positive by? It's a nice little trick that you can pop at the top of your periodic table. If I am in group 1, I am always going to form a +1 charge along with hydrogen. If I'm in group 2, I'm going to form a +2 charge. Group 3, a +3 charge. Changes a little bit at group 4. Group 4 can go either way. It can form a +4 by giving away 4 electrons, or it can form a -4 by taking in 4 electrons. You will not be asked about group 4 in your exams. Then we move on to group 5. Group 5 takes 3 electrons in, group 6 takes 2 electrons in, and group 7 takes 1 electron in. So they form -3, -2 and -1 charges. Now why is that? That is because they want a full outer shell, and a full outer shell would be to have 8 electrons in their outer shell, which is why our group 8 atoms cannot form ions. They are fully, they have full outer shells, so they don't want to accept or give away any of their electrons. So they don't get a charge at all. So we need to remember about that number 8 in this. It's going to be important. So if I'm drawing atoms, I need my information from the periodic table. So I might find the box on the periodic table with the elements that I'm drawing. And in this example, I've chosen to draw oxygen with a proton number of 8. Now that also tells me how many electrons that my atom has. So my oxygen here has 8, where it fits 2 on the first shell. And because I've used 2 up, I've got 8 in total. I've got 6 left to put on the outer shell. Now, little bit of a trick here. I know that oxygen is going to have 6 electrons in its outer shell because it's here in group 6. In our ionic bonding, you only need to draw the outer shell. So you don't need to worry about all the other layers and shells and how many are in them. You just need to know the group number which gives you the amount of electrons in that outer shell. Now you'll notice that I've paired up my electrons. This is for your benefit and your examiner's benefit. It'll be nice and clear for you to see how many electrons you've drawn, and it's nice and easy for your examiner to see how many electrons that you've drawn. Now, we've talked about wanting 8 electrons in our outer shell. You will notice here that oxygen has space for 2 more electrons. It wants that. It's going to want to bond with something else. So, how do we do that? There's a couple of ways. Today we are focusing on ionic bonding. So we are going to focus on when a metal bonds with a non-metal. So, my first example for you today is lithium bonding with fluorine. So, I could draw out my lithium with 2 electrons on the inner shell and 1 on the outer shell in my 2-1 structure. I can think about the fact that lithium is in group 1, so is therefore going to get a +1 charge. I already know my lithium is going to lose or give away 1 electron. Whereas my fluorine is in group 7 with a 2-7 structure. So I've got 2 and 7. And I already know it's in group 7, so therefore it's going to get a -1 charge. It's going to accept 1 electron. Now remember earlier I said you don't need to draw out the full structures. We only need our outer shells. So what's going to happen here is this lithium electron isn't going to stay with its lithium. It's going to give that electron to that fluorine atom. And because it's giving that electron to that fluorine atom, we can draw it in. And now the lithium has a full outer shell. It's got rid of that extra 1 around the outside and it's happy with its full outer shell, and our fluorine is happy with its full outer shell, with its gained electron from its lithium. So how do we draw that out? We draw that out by putting some square brackets around our outer shells. Now lithium here has given away its 1 electron from its outer shell, and earlier we've already said it was in group 1, it's giving away 1 electron, so it's going to form a +1 charge. Now our fluorine still has its original 7 electrons, but it has that additional electron from its lithium which it has gained. We've already said fluorine is in group 7, so it's going to form a -1 charge, and we can see that 1 electron it's gained to get that -1 charge. These two are now oppositely charged, and so they are going to attract. And it's that attraction that is very, very strong and forms an ionic bond. That's a really nice simple example where we've got 1 electron being transferred to 1 other atom. Sometimes things can be a little bit more tricky. So let's have an example where we've got something that's just a little more tricky. So calcium is in group 2, so it forms a 2+ charge, and it has 2 electrons in its outer shell. Fluorine is in group 7, so it's going to get a -1 charge, and it's got 7 electrons in its outer shell. Now, these 2 electrons need to go somewhere, and they cannot both go to this fluorine. This fluorine only has space for 1. Its maximum is 8. So, one of those electrons can be given to this fluorine atom. But what do I need? I need an additional fluorine atom for the other electron. So this electron is going to go to a second fluorine atom. So now we've got the calcium still giving away all the electrons it needs to, forming its +2 charge, but instead it's giving it to two different atoms. So let's have a look at what that would look like in our square brackets. So if this is our calcium gave away its 2 electrons, forming a +2 charge. Our fluorine still maintains its 7 original electrons from being in group 7, but it gained 1 electron from the calcium, leaving that fluorine with an overall charge of -1. That isn't all that happened. We still have that second electron from calcium reacting with another molecule of fluorine. Now you could draw this whole box out for a second time, or you can just pop a nice big 2 in front to show that 1 calcium reacts with 2 fluorines. Thanks for watching. Hope it was helpful.